So, hello and welcome to another Design and Make webinar for educators. This one is called Teaching with Sustainability, and it is our fourth webinar from the Design and Make series. So, I'm super excited to be back and be working with so many of you again. It's great to see some familiar names as well. So, thanks for joining us again. If this is the first time that you've joined one of our webinars, welcome. So my name is Jason Erdreich. I am a technology and engineering educator, and I've teamed up with the Autodesk and Tinkercad team to provide training resources like this, like these webinars, to teachers like you. And tonight I'm joined by a special co-host, Kellyanne. If you want to say hi.
I am super excited to be here. I am a youth programs manager on Autodesk construction business team. So very excited to learn from you and learn from Jason as we are proceeding with this awesome webinar.
Awesome, awesome. Thanks, Kellyanne. And listen, behind the scenes, there's a bunch of people in the Autodesk Tinkercad team that are always working to provide the resources that we're able to share and present. And with us, as always, Nicole is behind the scenes, and she's going to be the one that's actively working to drop some links in the chat and things as we go. So a huge thank you to Nicole and also the entire Autodesk and Tinkercad teams for supporting this webinar. So Design and Make series. This is, of course, our series to engage with education from all over the world of designing and making with different topics and things across Autodesk software, programs, and all the amazing things that you and your students can create. Tonight being all about teaching with sustainability and looking ahead. We have our next webinar, which is scheduled on April 11th, which is titled Engaging Students Through Robotic Education. Of course, you can check out our webinar page and the Tinkercad blog for more info because we do have all of the webinars scheduled between now and the end of May for the remainder of the school year plan. So you can see our future topics and themes. I know we have one coming up on working with lasers and also working with construction and architecture, which Kellyanne's going to be back for, and some other things planned throughout the rest of the year that you can check out. And that, of course, will be on every other Thursday using this link, same place and same time. So we're going to drop a poll on your screen here in just a moment, and we'd love to see what subjects or learn more about what subject and age groups you work with. So hopefully that pops up here in just a second. If you could let us know the subjects, and also the student age group that you're working with, that would be fantastic. It'll help us kind of curve the conversations from tonight's webinar directly to the things that you're engaging with. So I'll wait a couple minutes here, or just a minute or two, just to let you answer that. I appreciate all the participation. I'm also seeing a really wide range. So it looks like we do have quite a number of technology teachers, but it looks like we have a wide range of subject area teachers with us. Also, we have a wide range of teachers from all over the age group. So I see a number of high school teachers. It seems like the majority of us are, but also quite a few elementary and middle school teachers as well. So that's really fantastic. So thank you so much for your feedback. I'll make sure that I kind of curve these things to the people that are in front of me here, and we'll be able to tie these conversations to everybody that's joined us tonight. So thank you so much for answering that poll and giving us some insight to a little bit more about you. Now, how to participate, if this is the first one, we have, of course, our chat, which as you can see is super active, kind of scrolls really quickly, and we'll be using the chat to drop links to you, so you'll have different follow-up resources and things like that throughout. But the best way to participate throughout this webinar is using the Q&A button. So there should be a Q&A button on your Zoom if you haven't seen that yet, and that is where you can ask us questions. And the nice thing about the Q&A is that the questions stay there until myself or one of the Tinkercad team members with me answer them, and you can always go back and check out the answers and things like that. So if you have a question throughout the chat, throughout the webinar here, please just drop it into the Q&A. And again, we'll be using the chat to provide some links and things to you. And at the end of the webinar, after we go through the topics and things, we'll pause for a full-blown Q&A where you'll be able to ask teams to myself, Kellyanne, and Nicole, and we'll be able to answer those live here after we go through our evening's topics. Also, this webinar is being recorded, and the slides that you see will also be shared. So in the next day or so, we'll send a follow-up email that includes links to not only this webinar, but all of the past webinars that we've done as well. And these slides will be included in that because you'll see that there's some hyperlinks and some resources and things like that that we have. And I know that we have such a small amount of time together. I know that we only have an hour that we're already about 8 minutes into. So we're going to be moving kind of quickly. So it's nice to know that this is being recorded so you can always go back and play back this webinar at your own speed as you want to kind of review and recap all the things that we cover in tonight's session. So keep that in mind that while we will be covering a number of things quite quickly tonight, we're going to follow up with a bunch of takeaways and resources to support you and your students in the next day or so. So design and make, right? I kind of mentioned this a little bit earlier, but we want this webinar series to really engage with a wide range of topics that you might do with your students, from, creating 3D models to programming to creating simulations. We talked about SimLab a couple weeks ago, where we can simulate real world physics, working with circuits and things. We can make electronic circuits. So really providing our students with the skills, the resources, the knowledge so they can design and make anything. So we will absolutely be covering quite a few of these things in tonight's webinar because we're talking about sustainability, which is such a huge topic that realistically, we definitely couldn't cram everything about sustainability into just one evening, but we're going to try to cover some of the big topics and things like that, and how might you engage with the concepts of sustainability in your classroom. So, starting with a quick definition, what is sustainability? So, we typically consider sustainability as the ability to maintain or support a continuous process over time, right? So, what that means is that if we can do something continuously, typically with an effective and environmentally friendly mindset, we would consider that process to be sustainable. And I often hear, and when I personally was teaching, and I still do teach topics of sustainability with my students, that typically when we talk about sustainability, we're focusing very heavily on the environmental sustainability, like thinking about renewable resources, renewable energy sources, and those are absolutely great examples. But I love to point out and identify that there are a much wider range of topics within sustainability that are incredibly important for us, our society, our world, and of course our engineers and our problem solvers to be considering as we design a better future for ourselves, our future students, and all the generations to come. And I think one great resource that kind of culminates that and pulls all this together are the United Nations Sustainable Goals, Sustainable Development Goals, which I have here, and they're of course linked in this slideshow. And this is a great public resource with lots of great videos and things like that that you might find relevant for your students. And you'll see that they have essentially established 17 goals to determine how we can have sustainable futures, right? Talking, of course, like I mentioned, the renewable energy sources, renewable resources, but also looking at how can we, provide quality education, and how can we reduce hunger and make sure that everyone has access to clean and sanitized drinking water, those important things. So I like to bring these sustainable goals up because, provided by the United Nations, they are really well put together and relatable and real world relevant. But you can also use them to create fantastic real world problems for our students to engage with as we try to identify these things in the classroom. So when I mention that is teaching through an engineering design process, right? So there are many different engineering design processes out there, and depending on where you're coming from, you might refer to this as a couple different terms. For example, we often call this a design thinking mentality, or a design cycle, or a product life cycle. It's also very similar to the scientific method, whatever it might be. But essentially, it's an iterative approach to solving problems. And real engineers use processes like this every day as they design prototypes and solutions and products to help us improve our lives. And there are, of course, many different design processes. So this is an example from one of our Tinkercad lessons that we have on our website, but you can find a design loop that suits the language and the age group. For example, when I work with my college students, we usually use an 8-step design loop that kind of breaks the processes down a little bit more as we dive more into the researching stages of the design process. And when I work with my elementary school students, I have a 4-step design loop that kind of narrows the scope to allow students to problem solve more appropriately at that age group. But the concept is the same, that we provide students with a real world problem, for example, needing access to clean water, like we can pull from one of the sustainable goals. And then they work through a process to see how that's already been solved, brainstorm possible ways to solve that, maybe construct some type of prototype, a draft, a model, test their prototype, whether it's like a physical thing that we actually build some type of water filter, or even a theoretical thing where we theorize how we might be able to solve this problem, collaborate, sharing, and then of course reflecting, because there's never one way to solve any problem. And this really fosters teaching students not only sustainable mindset and sustainable goals, but also creative problem solving and methods to being effective problem solvers and creative thinkers, which can really, of course, curb and impact their futures in whatever they decide to do, whether it is engineering or just whatever they decide that they like to do with their future careers. Being an effective problem solver is, of course, a valuable skill to be able to foster at any age group. So what I mean by this, to kind of put this all together, and I have a couple lessons and things that we share before we dive into some of our resources, is we might take a sustainable goal or a challenge in the world of sustainability, whether it's social, economic, environmental, whatever it might be, and then provide students with some type of real world problem that they need to try to solve. So we have a collection of Tinkercad lessons on our Tinkercad page, and we can see that there's some links dropped in the chat that you can see. This lesson was actually written by our very own Kellyanne, who's here as a co-host here. And the idea was, hey, flooding is a challenge, right? And it talks about some real world statistics about coastal areas that have, challenges with flooding along the coastlines. And students are challenged to design some type of solution. And they have to create some type of solution to support this challenge. And it brings in topics of, climate change and all these great things that we should be letting students think about in the classroom as they're also learning not only problem solving skills, but real world CAD skills and things like that as well. So providing them with this real world challenge and then letting students think through possible solutions and designing it with a sustainable mindset. Another great one from the Tinkercad lessons plan page is design thinking for pollution problems. So this lesson showcases some challenges that we have in pollution, a wide range of pollution, and students have to design solutions to potentially reduce that pollution. And I want to, if you've never seen the Tinkercad lessons, I know the links are in the chat here, but I want to also just flip my screen so you can see what the Tinkercad lessons look like. So they're broken down into steps, and these are all public and, of course, free resources on our Tinkercad page that you can find right here when you go to tinkercad.com. And we'll break them down. They're kind of organized by grade, but that can vary a bit depending on where you are in the world. And in addition to providing you with the lesson overview and evaluation rubric, there's lots of great videos and things like this, and steps and resources and tutorials to help you work through these types of topics with your students. And there are a number of lessons and things. I'm only highlighting a couple that really relate directly to sustainability tonight, but this is definitely a great resource for you to check out if you haven't seen this before on the Tinkercad page. Let me just bring back my slideshow here. Okay. In addition to these lessons and providing students with kind of this real world problem and having them think like real world problem solvers, we also just have a number of challenges and mini challenges. So I've highlighted a couple of our favorite ones from the Tinkercad community here. Like, for example, challenging students to think about gardening. Maybe they have to design some type of greenhouse or garden, and they're using Tinkercad to create a 3D model like this. Tinkercad user created this great garden here, taking advantage of not only the different shapes and the design features, but designing a potential prototype solution to, solve a problem, talking about, growing food and crops and things like that as well. So when we say prototype, it could be a physical model that we hold, but designing a model like this, a virtual 3D model in some type of CAD and software like this is absolutely fantastic and a great use of our design skills. Working with renewable energy is also great. So I love to challenge my students to think about their town, right? And then how could we potentially improve our town by, maybe redesigning the layout, bringing in more trees, bringing in renewable energy sources, or even, let's say, for example, we hypothetically hire our students to work for our school district. How can we make our school more sustainable, more environmentally friendly? So this is actually a model of a renewable energy. I believe these are like townhouses and things like this. So this user designed some type of town here and made it a little bit more energy efficient with different types of energy sources, a nice garden, things like that, all using the 3D modeling and CAD skills. Working with architecture is fantastic. I saw somebody mention in the chat like LEED certification and things like that. We'll talk more about these types of contests later on that we have going on. But challenging students to think about this type of green design, right? What if we were going to design a more sustainable home? What materials will we use? How would we lay out that home? Where would we locate it? What type of shading would we want to do? What type of energy sources would we want to do? So this is another great project that students can use their CAD skills for. And also working with sustainable materials, right? So we'll be talking more about this as well as we get into building and things, but working with, recycled materials. So if we're prototyping, challenging students to bring a recycled material in, use that as part of their design. And it's really great to see that students can actually design with those recycled materials in CAD as well. So in Tinkercad, they could be designing with these materials as they go ahead and create their prototype solutions, like this popsicle stick water bottle boat designed by a Tinkercad user. And of course, depending on your classroom and your environment, I'd love to see students then taking their designs off the screen and building things hands-on. Again, that varies depending on the environment that you're in. But we might use CAD as a design space, a simulation space to make a prototype, an iteration within our design process that I mentioned earlier. And then students would take that CAD design and bring it to the real world, whether they're using something like 3D printing, which we've spoken about in past webinars, or laser engravers, which we're speaking about in future webinars, or even they just use their CAD models to construct it. So for example, there's a milk carton like this one in Tinkercad, and you can make little pieces of cardboard. So students might prototype their design of the birdhouse like this in Tinkercad before they then actually go ahead and building it physically in the real world. And I'm just going to back up because we could do that with this popsicle stick boat. So this is like a scale water bottles and popsicle sticks and things like that that we can design in CAD before we then go ahead and build this in the real world. And don't worry, I'm going to get into CAD to show you how to do some of these things in just a minute. Just want to get us thinking about some of these great projects before we do. And then where could students go? I know that we have a number of high school teachers with us here. So where are the next steps? How could we elevate these skills and how could we get students even closer to those real world careers? Well, of course, Autodesk has a lot of different programs that's used by actual professionals and engineers in the world designing sustainable solutions. Like, for example, this is a screenshot of Autodesk Revit, which is an architectural program. So, architecture and engineers and people that make buildings and things like that are civil engineers and all those lovely folks that design the buildings and structures we work in every day, use programs like Revit to actually design sustainable buildings that are energy efficient. They can calculate that and they can determine those things with these real world skills. And that would be a great way to elevate this Tinkercad greenhouse project I showed earlier into a kind of career centric environment, as well as we kind of elevate these skills closer to what professionals are doing. And then something else that we spoke about briefly in some earlier webinars about Fusion is also being sustainable with our material choices, right? So one thing to be able to create things more sustainably is to conserve materials, make sure that we're not wasting materials, right? So let's say that we're 3D printing a prototype solution. We can make sure, or we can strive to use, let's say, an environmentally friendly filament. A recycled filament would even be great. I've seen some really cool filaments that are made from recycled plastic or recycled fishing nets, which is really cool and exciting. But this actually image here is showing generative design, which is a Fusion 360 feature that allows us to design our models to be incredibly efficient, reducing waste of material and things like that. And this would be a great next step to kind of elevate our 3D design skills if students want to then elevate and level up to Fusion as they get older and as they get closer to potentially thinking about these things as they consider their future careers as well. And also, I've kind of touched upon these things, but two of my favorite ways personally to bring sustainability into the classroom is to, of course, work with recycled materials. So challenging my students to work with, like, let's say, for example, we're going to 3D print something. Maybe I'm making some type of puzzle or some type of challenge like that. I might challenge my students that their prototypes have to be done with at least one recycled material. So they have to bring in a recycled item, or they have to do like an upcycling project where they take something and turn it into something different, like this milk carton that turns into a birdhouse. And then also teaching with constraints. There are a lot of different ways to teach with constraints, but what I mean by that is to make something more real world. Constrain your students to a certain number of materials, right? So you only have this much cardboard or this many popsicle sticks, whatever it might be. And you might do that in a couple of different ways. You might literally have a number on it, or maybe you do something like a class economy where students have a certain budget to work with the project. Like maybe they have $100 and each item's worth a different amount of money. And that's also teaching financial literacy skills as well. But that challenges students to be more conservative with their materials, make sure that they are thinking about both economic sustainability as well as their material choices. And at one point in time when I was doing some design thinking and other workshops like that, somebody brought up the point that, well, if we limit students to materials they can use, that actually limits the open-endedness of the problem. And arguably that might be true, but I find that if we challenge students, if we say to our students, design something with anything you want, a lot of students might find that really hard. If we challenge them to design something within constraints that actually fosters greater creative thinking, greater problem solving, and also, of course, is much more real world. So if we are these real engineers and things like that, we have a budget, we have time limits, we have things like those we have to work around. So this allows us to bring more real world challenges into the classroom. So I've seen lots of great questions and things. And again, a huge thank you to Kellyanne and Nicole for working through the chat and helping me support these topics. And now what I'd like to do is dive into applying some of these concepts in Tinkercad, one of our favorite programs that I know is probably a favorite for many of you as well, to see how we can do some of these projects. And if you haven't, if you're not familiar with Tinkercad, I know that we have a couple new users with us here. Tinkercad has 3 different design spaces, and we're going to be looking at 2 of them tonight. But I know that we've mentioned the past webinars and things like that, where you can always go back and learn more about the spaces that we're not really going to dive so much into in just this one. But in the 3D design space, this is where we can actually be making these 3D models, which I kind of showed you some of the projects earlier on, the boat, the house project, things like that, manipulating shapes to create really just about anything. And those shapes can be, downloaded for 3D printing and things. They can also be exported for laser engraving, which we'll be talking about in 2 webinars from now. But they can also be great simulations and models that students can work with as they're designing their prototype solutions on the screen. We also have circuits, which we'll look at briefly tonight, where students can be simulating and fabricating electronic circuits with real-world components like this, so they can actually wire circuits, test to see how the current would flow, and even make sure that they have the correct amount of voltage and resistance to create real-world circuits, even bring in microcontrollers to do some computer programming. And then we also have code blocks, which we're not going to be talking about too much in tonight's webinar, but code blocks is a really exciting way for students to engage with computer science and algorithmic thinking, as they can actually develop a block-based program like what you see on the left of the screen here, and that program creates a 3D model. So they can create 3D models using code, and students can actually bring those models into their other 3D designs if they like. They can even download their 3D models and 3D print them or something like that as well. So a super exciting way for students to engage with algorithmic thinking. And Tinkercad can be accessed anywhere. So if you have a tablet or a Chromebook or a laptop or something like that, you can access Tinkercad in a web browser or via the Tinkercad app. You can also access Tinkercad completely for free. It's free for everyone. And of course, both students and teachers can create accounts. If you are a teacher, you have some access to creating classes and things like this, where you can organize your students, their work. You can even invite students to join your class. If you're a teacher and you'd like to create accounts, you can do that as well. So you can actually create student accounts that you can manage. And this is a great way for educators to kind of be able to support their students as they create, which is super exciting, as well as creating activities and things like that. Tinkercad Challenge is a newer feature that we launched a little bit ago. So these are kind of like mini challenges that the Tinkercad team puts together with constraints like we just talked about, through design thinking, through engineering problem solving, to challenge students to apply their Tinkercad skills in a real world way. And we love to also see what students are creating. So if they share their designs with us, which isn't required, but if they do share them, we can feature them on our pages and things like that. And all these challenges are timed. But even after one of the challenges ends, you can always go back and see the past challenges. And I always find these to be great themes and mini projects to bring into your classroom. And I mentioned this a little bit earlier, but bringing your Tinkercad designs to Fusion is super easy to do. And we'll actually be talking more about this in our robotics education webinar that we have planned in 2 weeks. So we're going to be looking at how to actually take your designs and bring them from Tinkercad to Fusion. This is for our older students because there is an age requirement depending on where you are, or everywhere in the world. That varies a little bit for depending on where you are. But this is a great way for students to bring some of these more career-focused concepts into the older student classrooms, like high schools, as they're working with these types of things. And with that, I'm going to flip my screen and switch over to a Tinkercad design that I have here, to be able to kind of go through some of the concepts that we have been talking about. So here's my Tinkercad design space. And if you've never worked with Tinkercad before, again, we're in the 3D editor, and I'll show you the circuits editor in just a bit. Essentially what you can do is you can grab a shape from your basics shape library here, and you can change the scale or change the size of the shape by just manipulating it like this. You can also type in specific measurements. So if I knew exactly how big I'd want something to be, I could punch in those measurements into these dimension boxes here. You can customize your workspace by pressing the settings button. We talked a lot about this in our Artscapes webinar 2 weeks ago, where we can customize the grid. We could change the unit that we want to work in. We can also change the grid size and things as well. And of course, we can change the color of our shapes. So let's say, for example, I'm prototyping something like a sustainable design. I might say that I'm going to be working with a piece of cardboard that is 50 millimeters by 50 millimeters by 4 millimeters, and I'm going to make it kind of a cardboard brown here. So this could represent my piece of cardboard that I'm working with, and maybe I actually rotate this around, and I could copy and paste this and create like a little cardboard box in my hypothetical prototype here as I go. Now, let's say that I actually want to cut some shapes. So maybe I am making a cardboard box like this, and I want to cut some type of opening. Well, you'll notice that we have solid shapes with color, and we also have these hole shapes here. So I can grab one of these hole shapes and drag it out and manipulate that here. And if I select all my shapes by highlighting them, when I group them together, the whole shape will cut into the solid shape like this. And we have a lot of different tutorials and things like that on our Tinkercad Learning Center, and they're going to be linked through the slides and the resource that we're going to share. So of course, while we're just covering these things rather quickly tonight, we'll be diving way more. There's a lot more resources that we'll make sure that you leave tonight with so you can learn more about these things if this is all new to you. And I also want to point out that while we have two hole shapes here, any shape can become a hole shape by toggling between the solid or hole feature. Now, something that I don't know if a lot of you know about is that in addition to these basic shapes, there are many other shape categories. And one of my favorite categories to work with is the everyday objects category because, as the name says, it has everyday objects that we can find. So this is a great opportunity to bring in some everyday objects to be working with our prototypes, especially when we're thinking about sustainability. So for example, here is a milk carton. And you'll notice that it's labeled here 1 quart, right? So this is actually a scale accurate size of how big this milk carton would be, right? So perhaps if I did want to turn this milk carton into my birdhouse, maybe what I could do is grab this everyday object and head back to my basic shapes here and create a flat panel like so. And I'm actually going to use this cruise feature to be able to bring this up and put this on top of my milk carton like that, something like so. And if I duplicate this, I should be able to do it again on the other side, something like that, I think. And then, of course, I think we need an opening here. For our birds, something like this. Let's bring this in here a little bit. And maybe give our birds a ledge. Now I'm just making things up, but I think this looks very birdhouse-esque. Let's see. So if I group this to this, I should be able to cut a hole in my birdhouse like that. And if I group all this stuff together, I should have my birdhouse. And maybe I change the color so it's not multicolor. I could even make it blue, like the one that we looked at earlier on, right? So some type of prototype design here as we are working with these everyday objects, which is super cool. I like the applause. Thank you. I need that. And then another everyday object that I love working with are these toilet paper rolls, which are super great. These cardboard tubes and things like that. And also, I think we have some paper cups, which is great. And somewhere in here, there's even a water bottle, right? So I mentioned that a lot of times what I do is I challenge my students to bring recycled materials into their designs, into their prototypes, that they might also be 3D printing, right? So let's say, for example, we're going to make something like an acoustic phone speaker. And what an acoustic phone speaker is, if you don't know, is essentially a device that amplifies the sound waves without any type of electronics. So there's no electronic circuits involved or anything like that. It's just something that would actually amplify the sound waves of our phones or whatever devices we decide to put in here. just by simply sending the sound through a series of tunnels to increase the magnitude of the sound waves. And that was a very, very, very quick crash course on what I'm trying to do here. But maybe I want to 3D print this piece that I am designing in red. So this piece that I'm designing in red would actually be 3D printed, hopefully using a recycled material or a material made out of recycled fishing nets, which is super cool and is currently my personal favorite 3D printer filament that I've been using lately. So I'm just designing this here, this nice little part that's essentially going to have a slot for my phone to fit in, like this, a nice little base. Maybe I can rotate this here, and I'm not really putting a whole lot of care into my measurements. So that's definitely not the best way to do this. If I was going through the design process, I'd put a little bit more time into my sketching, my brainstorming, right? But I have this piece here. So this part in red would be 3D printed, okay? And that would be my students' constraint of how much they might be able to 3D print. I might constrain them to only having, 100 cubic millimeters or something like that of filament that they could work with. And then the rest of their design, they would have to use everyday objects, like, for example, toilet paper rolls or something like this, right? And I'm actually going to just increase the scale of this because I didn't measure. So let's say that it's going to look something like that. And maybe they take their cardboard tubes and they cut them to length, right? So they can combine some cardboard tubes into their design like this. Maybe I provide them with hot glue guns or something, depending on the age group and what resources I have available to me. So we can put 2 cardboard tubes on the side like that. And let's grab this water bottle here, and I'm going to use a box shape to cut this water bottle like so. So if I was using scissors to slice this water bottle like this, might take a second to load. It's kind of a complex shape. But if you ever see red like this in Tinkercad, it just means that it's loading your design. And I also want to create this to be a transparent or translucent water bottle like that. Okay, something like this. And I need to poke some holes in the side of this guy so I can connect it to my cardboard tube. So if my students were designing this to actually manufacture this part, right, this prototype in our acoustic design challenge, right, where they're designing these types of acoustic devices, whatever it might be within the constraints, where they have to use a certain number of recycled materials, a certain number of 3D printed materials, whatever it might be, right? Sketching is a really fantastic way for students to start to brainstorm their ideas. But to elevate that to their next iteration, their next prototype design, using Tinkercad to create a 3D model that's not just their 3D printed part, but actually shows how they might have to cut these things to actually allow them to come together to be manufactured and assembled like this, so they can start to visualize how they'd actually need to create this and build this using the everyday objects is a really fantastic prototyping skill. So even if we do plan on building this physically in the world, in the real world, with these actual materials, we just came up with another iteration of our prototype design, of our little acoustic phone speaker thing. And I think there's even a phone model in here somewhere. There is. Look at that. I can grab this smartphone and drop this into my acoustic speaker, something like that. And we now have our sustainable prototype design as an acoustic device to amplify our sound waves here using a variety of materials. So another fun, exciting project. Something else that we might consider doing, which is a super fun feature, is working with our physics simulator called SimLab, which we took a look at a little while ago. And the way that SimLab works is essentially it allows us to apply real-world physics to our models. So I'm going to real quick make a super simple SimLab simulation here, where perhaps I'm going to make my work plane a little bit bigger to give us a little bit more space to work with SimLab. Okay. Essentially, let's say that I have a ramp, and on the top of the ramp, I put a ball, like so. And at the end of the ramp, I put some type of box, like this, maybe several boxes. like this. Now, if I were to do this in the real world, I need you to visualize with me here. Let's imagine these are wooden blocks, and I actually set this up on my table, my desk in front of me. What would happen to the ball? Well, we would assume that it would roll forward and knock these boxes over, right? So SimLab allows us to test just that. So I push this little SimLab button here, and I can apply material properties, which means I mentioned that imagine these are blocks of wood. I can actually click on these and set them to be wood, hardwood or softwood, right? And what that does is it tells SimLab what the density should be, how much mass this object should be. I could say maybe this ball is like a rubber bouncy ball or something like that. And I could also say that, you know what, this ramp is fixed. This ramp shouldn't move. And I can set that to be a static object by pushing this button right here. And when I push this play button, physics will be applied like that. So the ball actually does roll down the ramp, and it does knock over my blocks, and it's super fun because you can rewind this and see how that actually interacts. And your students can, engage with different materials. Like, for example, what would happen if these weren't wood? What would happen if these were styrofoam, right? So let's make these styrofoam instead. And now let's run it. And they went way farther, right? So we can actually engage with different materials, which is super fun. So as we're talking about sustainability and students are designing their prototypes and simulating their prototypes here, they can consider how the materials they choose might interact in the real world. And I'm going to bring up the lesson that we show earlier about flood prevention and things like that, which was one of Kellyanne's lessons, where perhaps what students have to do is they have to create some type of flood barrier. And maybe we have a huge ramp like this with many, 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 many spheres. And I'm not going to put too much time into simulating this whole thing right now. I think you'll get the idea, but I could put many spheres. We can call this like rushing water and things within the design. So we can have a couple spheres like this. And this could be the rushing water. And on the other side of this very large ramp could be a small town. And students need to be able to protect this town by designing some type of prototype solution that can deal with these rising tides. And maybe they design some type of wall like this. And I'm just going to make this a little bit bigger so we don't fall off into the abyss. And when we run into SimLab, we can test to see if we can actually protect that town, right? Or how our flood solution or prototype solution might interact as we go with different materials and things like this. And right now, SimLab can simulate gravity. So we're seeing like real world physics through gravity. But I know in our SimLab webinar we had a little while ago, they're continuing to add more and more features to SimLab. So stay tuned because we have some exciting things on the way. And perhaps, let's say, even for example, and I know I've been talking about this for a little bit, we have a couple more things to look at. Let's say that we're going to design some type of turbine, right? Some type of renewable energy source where students are designing a wind turbine or something. And maybe we want to prototype that. We want to see how that spins. One of the newer SimLab features is creating connectors. So we can do kind of real world movements, axle connectors and pivot connectors. And we talked quite a bit about that in our SimLab webinar, which we have recorded. So you can always go back and learn more. I'm giving you a crash course tonight. But we can create these axle connectors if I just create this wind turbine, which is absolutely not perfectly balanced. So I don't know if this would actually be the most efficient wind turbine in the world, but it'll do for tonight's crash course on SimLab. It's actually not even connected very well. Okay, definitely not the best turbine I've created, but it should work. It should do. So if I come on over here and if I go to SimLab, we'll see if I can get this to pivot. So if I drop like an axle connector right on the surface here, like this, I can tell it what's moving, and we'll see if this rotates here. I can try to throw something at I have to actually give myself an axle. That would help. Please hold. let's give us an axle to rotate around. And perhaps that would be helpful. Okay. Not the best wind turbine in the world. I challenge your students to do better than this, but nonetheless, we should be able to create our mock turbine here. Let's give that a go again. And what I was doing before, I didn't make this super clear, is if you have an object that doesn't move, you can throw objects at it like this. And my very unbalanced turbine isn't spinning in a perfect circle here, but we get the idea that students can actually challenge their movements as they go. And they can see, hey, this wind turbine blade is not balanced, and that's not going to spin really well. And they can test out their prototype solutions as they're designing them, which is super exciting as they're working here. So 3D designs, fantastic space to be working with our different models and things like that as we go. So they can design a space, they can design a model, they can work with their everyday objects and things like this to design prototypes. And if they want, they can bring in some real world physics through the SimLab editor as well. And another design space I want to show you, because it's a great way to bring in sustainability, is the circuits editor. So when I'm in my Tinkercad space, I can flip between the 3 design spaces like this. And if I head over to circuits, I can make a new circuit project. And we have another webinar on this that you can always go back and find another recording where we talk way more about circuits than we're going to do tonight. But essentially in circuits, what we can do is we can grab electronic components like a battery, a light bulb, even a switch, and I can connect these components like I would if they were physically in the real world, where I can wire them together. I can even change the color of my wire to keep myself nice and organized. And Tinkercad circuits will allow me to simulate how the electricity, how the current would flow if this was actually built in the real world. So I can actually flick the switch and see that my light turns on. And it's really cool because it also will tell you if you're going to do something that's not super great, like potentially something that's a dangerous circuit. Like, for example, if I grab a 9-volt battery, which is way more energy than we want to have with our single little LED, and I wire this to my LED. Let's see what happens. I know in the real world, my LED would not make it through. And in circuits here, it also shows me that, hey, that's way too much current for the LED. So it's a really safe and exciting way for your students to be prototyping and designing their circuits as they are working here with electronic components. But I bring this up in sustainability because you'll find that there are a lot of components that might be helpful for a sustainable project. For example, we have solar panels somewhere in here like this. So students can be prototyping circuits with solar cells. We even have fun things like potato batteries and lemon batteries that we can use as an alternative and a green energy source as we go. There are things like motors. So let's say, for example, we wanted to expand upon our wind turbine project. I could potentially be prototyping with a DC motor like this. There's even things like sensors to work with soil moisture sensor and also microcontrollers in here as well, like the microbits and the Arduino Uno, that students could be programming the soil moisture sensor to, of course, detect if our plants are running dry and automatically adding some water and things like that. So if I just grab my solar panel, you might be wondering, how could we simulate sunlight here in our circuit simulation? I'm going to search for a component because there's so many. If I grab a multimeter, this is a tool that allows us to measure current, voltage, or resistance. And I'm going to wire my multimeter to my solar panel. When I run my simulation, we can see that this is currently outputting 5 volts, 5 volts. And if I click on the solar panel in the simulation, I can simulate how much sunlight this panel is getting. So if I move it all the way over here to the dark dot, 0 volts, that means like no sunlight. And as I move this up, I can see what it would look like if we have a lot of sunlight, right? So this allows students to potentially simulate what their circuit should look like. Let's say, for example, we did want to create some type of, I don't know, solar powered light, perhaps. I could grab an LED, and wire my LED to my solar panel and simulate creating that solar powered light, whatever it might be. It's just really nice to have this component that your students can work with as they're working with their different 3D design spaces as we go. So that's a crash course on circuits. And I know that we have some resources and things on past webinars and things that we talked about and working with Tinkercad circuits. And I saw a number of questions come up about the classes and the activities and things. So let's say that you are challenging your students to do a real world problem like this, a real world project. Let's say, for example, I'm challenging my students to create that acoustic amplification device. Well, I can create a class. So I have a class here. And within my class, I could create, and if you don't have a class, you can hit this nice little create button to make a new class. And to see this, you do need to make sure that you sign into Tinkercad as a teacher when you actually log in. So you can see this button here. And after I create my class, I can add students by sharing a link. If I wanted to actually create student accounts, I just updated my account here. I can actually create a student account or paste in a list of students and give them a nickname, and then this would be a managed account, but they can also sign in with their own accounts as well, and then join using their class code. And then in the activities tab, I could make an activity, like I could, for example, call this acoustic device challenge. And this could be where my students are challenged to create that acoustic speaker that we saw earlier. And when students join my class, they see this challenge. They'll see the description I list. They'll see if I want to give them a starting thing. Let's say, for example, I want my students to see and start out with a water bottle and a toilet paper roll. I could make a design that they start with. And whenever my students submit their designs, I would actually see their submissions here. And I think I have that. So in the sample activity, this is designing a holder for expo markers. You can see that this, I am signed in as a teacher. I could see my student work. And this would look exactly the same if I posted a 3D design, a circuit design, a code blocks design. So this is a great way for teachers to be able to see what their students are doing, look at their projects, maybe even sign in and go to a student project like this, even leave them some notes and feedback like that. And then students will be able to see the feedback that you have. And it's a great way for teachers to be able to support their students as they design and create in Tinkercad. So that was our crash course on Tinkercad for tonight with a mindset of sustainability. And in the slideshow that we're going to share, our follow-up slideshow here, everything I just said is also linked in here with its own little slide. So not only are we going to have this recording, but I have a slide dedicated to the couple different topics and things that we talked about into tonight's webinar. There's a much better turbine than what I created tonight. But nonetheless, you'll be able to go back and see these things as we dive in. And before we go into our Q&A, we want to talk about just a few more things. And again, you'll see that there's lots of links here. So this slideshow is going to be shared with you in the next day or so with the follow-up email that we send to all of our attendees. So you'll be able to go back and click on all these links to the challenges, the blog posts, the lessons, and the things that we've talked about. And included with that will be a certificate for 1 hour of professional development for all of you who joined us here live. So thank you, of course, for being here. We're going to send you that PD certificate in our follow-up email. And before we go into the Q&A, I'm going to hand the mic over to Kellyanne to talk a little bit about Instructables and some of the great things we have going on there.
Thank you, Jason. That was so much fun to watch. And now it's exciting to think about, like, how can you engage your students in fun projects via the Instructables website, where there's tons of inspiration, lesson plans or lesson project ideas, but also really fun contests. So that was what I'm here to speak about. So one of the really fun student design challenges that we have running right now that offers gift cards in denominations of $500, I think all the way down to $50, is a student design challenge that is very relevant to the topic of this webinar. So green future. So this is a Autodesk Fusion challenge. So students must be of a certain age, for example, in the United States, 13 or older, in order to enter this contest, because they would need to use Fusion to design some solutions to help power our future into a more environmentally sustainable planet. So this closes on May 13th. So check that one out. Engineering in the kitchen, this is so much fun. The spork did not always exist. It was something that someone invented, thought about a fork in a spoon, could we make it one thing? That's kind of an example of the premise of this contest. So thinking about ways that you can either make a CAD model to design something like a new kitchen gadget, or it could be like a way that you're experimenting or even using STEM in the kitchen. So this is for high school students, and college students can
Okay.
also enter these ones. Another one is made with AI. So ways that your students can either use like Chat GPT or even some generative design algorithms within Autodesk products. So within Fusion, there's generative design. Revit also has Dynamo, which is generative design for the architectural industry. So check that one out too. I think it would be super fun. Remake it. So just thinking about similar to like the spork, thinking about how you could reimagine a chair to make it better, or reimagine something in your community in order to solve a problem in your community. So this one also closes on May 13th. And you can use any type, I believe, of Autodesk tool in order to enter. Last but not least, the Make It Resilient contest. This is actually a program that I manage for Autodesk. This is offering $50,000 in prizes in the form of two $10,000 scholarship awards, four $5,000 scholarship awards, and 10 $1,000 scholarship awards. Sadly, this is only open to the United States and Canada, but we do hope that students find inspiration in this contest. This year, the challenge is to think about how you could be inspired by an extreme environment in order to design a new habitat that is livable and enjoyable for humans, but at the same time is kind of embracing that unique environment. So it could be space, it could be the Arctic, it could be a rural place that has limited infrastructure, it could be a place where there's coastal flooding. So do please check that out. We're excited to see your designs, and this closes on June 24th. And we've been doing Tinkercad challenges. We'll have a new one on Monday that are relevant to this. So we did the Arctic Habitat Challenge that just closed on Monday, and we'll be doing an Aquatic Habitat Challenge that's going to launch soon. So please check that out.
Awesome. Awesome. Thank you, Kellyanne. A bunch of great contests and also ones that really directly tie to a lot of the things that we talked about tonight too, which is super exciting and still plenty of time for students to participate in that. And even I always found that even if students necessarily maybe weren't the age group that could participate, or even if they didn't want to publish their ideas, these are still great topics that you can bring into your class to challenge your students through these real world activities. So checking out the Instructables contest, the Tinkercad challenges, just to give you some themes and things to bring that real world mindset into our classes are super exciting and a great thing to do. Looking ahead, same place, 2 weeks from now, we'll be talking about engaging students through robotics education. That one's going to be super exciting. I personally coached robotics teams at the middle school and high school level for a number of years in a couple different competitions here in North America. So I'll be super excited to share some of those great things and looking at different strategies and skills and tools in both Tinkercad and Fusion and a bunch of other great resources to challenge students to engage with robotics education on April 11th. And I think before we can sign off, we have a bit of time left here. So we have some time for the Q&A. But before I do, I just want to again say a huge thank you to all of you who attended here live with us tonight. And also a big thank you to both Kellyanne and Nicole for helping me host this webinar and answer all your questions. It was a busy night in the chat and the Q&A. So a big thank you to both of these lovely people that have been with me all night to be able to manage this, as well as the entire Autodesk Tinkercad team that helps create these resources that we were able to talk about tonight. So a big thank you to all of them. And again, to all of you.